All right, so I am reading. Make sure I'm on mute. Yep. I am reading pages 72 through 76 of Machine Learning by Tom and Mitchell. Um, this is the end of chapter 3. Um, and, the rest of the pages are just a summary. So, up until this point, we've only been able to deal with discrete discrete set of values for attributes, and also for the target function, um, or the target attribute. But ID3 can, in fact, include continuous valued attributes, and that's what this section is about. So if we take our play tennis example, and instead of having temperature as, hot, warm, cool, cold, and turn it into, whatever temperature, that's a continuous variable. The way that ID3 does this is that it turns it into a discrete variable by picking a threshold, actually a binary variable that has the most information gain. So, for example, it tests different limits on where that midpoint should be. So if it gets the most information gain from saying below 25 degrees or above 25 degrees, it picks 25 degrees. If it gets the most information gain from 20 degrees, then it picks 20 degrees, and turns it into a binary or a Boolean-based attribute. You can also do it. It doesn't have to be a single threshold. You can do it over a few values. Maybe picking the values, maybe you split into 3 values, and the 2 midlines are that it would pick are where the most information gain is. So there's that. Then it goes into alternative measures for selecting attributes. So it gives the example of what if you have what if date is in your data. Like, let's say if this is days to play tennis and the date goes all the way back to 1923. Date alone would perfectly classify those instances based on the train data. But obviously, in the validation set, it would have no basis for being able to classify it in the validation set, because if it's not necessarily that April 4th, 1923 is a good predictor for April 4th, 2023. But your algorithm would think so because it would be just your tree would have a depth of 1, and it would have very high information gain. So they go into a few different ways in which you can avoid that. You can use what's called gain ratio. This penalizes this basically penalizes you for picking a attribute that splits the data broadly and uniformly, if I'm understanding that correctly. So that's the gain ratio. Then they go into using, instead of the gain ratio, you can use a distance metric. I don't think any of these are really crucial to understanding the overall context. He's just giving some alternatives in case you include an attribute that, like, an alternative way to select attributes. So there's that. And then handling training examples with missing out attribute values. So in your data, of course, there's going to be missing values. There's a few different ways you can deal with those. You can assign it to the most common. So for example, if in the play tennis example, if there's like half the temperatures that are missing for whatever reason, they don't have the temperature, you can assign the missing temperature to whatever is most common for that classification. So for example, if there's a lot of days that say yes, or where play tennis equals yes, and there's missing temperature values for that, you can assign the most common temperature value where play tennis equals yes. So that's one way to do it. A second way is to assign a probability to that I guess branch from the node. So for example, you can, if we're using the weather, or what is it? It's not weather, it's like sunny, rainy, or cloudy. You can assign a probability for each of those, how probable it is that that's going to happen if that's missing, based on the other values. And then that's multiplied by the information gain, so that ones with less probability have less information gain, if I'm understanding that correctly. And then you can also, another thing they go into is handling attributes with different costs. So you can add cost, basically divide your information gain by some metric of cost, depending on how high you want that cost to be. Obviously, if you divide the information gain by the cost, the information gain is going to be less the higher the cost is, and therefore your algorithm will value attributes with lower costs before it values ones with higher costs. In the situation of, I don't know, let's say you have an example with trying to diagnose patients, and you have temperature, biopsy result, pulse, blood test results, and MRI. It's going to, they don't want to be handing out MRIs just, whatever, all willy-nilly. So you're tuning your machine learning algorithm to try and make its determination or its decision on whether this person might have cancer or whatever it is, based on the less costly factors. And if you can get it better doing that, then you don't have to do as many MRIs, is basically what it's saying there. So you can incorporate costs into your algorithm. So there's that. Wow, that's the end of chapter 3. I think I did like 9 videos for this chapter, so thanks for sticking with me, if you did stick with me. And it helped me, hopefully it helped you, and I'll see you in the next video.